Okay, so well, today's lecture is going to be about LDK. There are going to be two different. We're going to be two different lecturers. So I'm going to do the morning, and somebody from LIPA, I don't know who exactly, is going to do the afternoon. My morning session is going to be first, just showing what LDK is a little bit, looking at the like introduction documentation on their website, maybe looking at the docs itself, of the Rust documentation itself as well. And then for the second part of the lesson, so after the break, we're going to try doing an exercise. So for the Kubo Plus students, they've already done it. So they're going to have to do it again. I can show you maybe very quickly what we're going to do later. Okay. So first, we talk about LDK, and then in the second part, we can try doing this workshop, which was set up by Tinal, is one of the developers working on LDK. And basically, in this workshop, you start from pretty much an empty project, and you have to implement all the most important pieces of a Lightning node yourself in order to be able to spend an invoice. So you're going to start with basically an empty, almost empty main file, and then you include, you start writing all the pieces, and at the end of it, you should be able to open channels and send payments over your own, in a way, Lightning node that you've assembled yourself. Anyway, I'm going to start with the more theoretical part. So basically, LDK is a Rust library that's a full implementation of a Lightning node, but instead of being like a daemon, like for example, you could be familiar with C Lightning or LND. Those are full node implementations that you can get as a daemon. You run this on your computer, and they are like their own kind of closed piece of software in a way. You cannot really change the way the node behaves all that much. You can interact with it, obviously, but it's kind of its own thing. And instead, with LDK, you have all the components as kind of primitive components, and you can assemble them yourself, which means that you can assemble them in whatever way you need, whatever way works best for your project. So you can also replace some components if you don't want to use them. There are default implementation of most things. So there's a default implementation of keeping track of the blockchain. There's a default implementation of signing transactions, so like an on-chain wallet that signs transactions. But you can replace those with other components if you want to. So maybe we can look at the docs. Yeah, so well, first we can talk about the use cases for LDK. So other nodes like, again, C Lightning, LND, they basically work only as full Lightning nodes on a machine running 24/7. So they're not really designed to be used, for example, on mobile devices, because again, they kind of the way the software is developed, it kind of assumes that it's running 24/7. And instead, with LDK, since it's a bit more flexible, you can kind of adapt it and use it in a bunch of different ways. So for example, you could use it for mobile devices. So you could create something more similar to Phoenix wallet, something like that. Phoenix doesn't use LDK. Phoenix has its own, don't remember the name, its own library written in Scala. But you can basically recreate the same kind of user experience where you have the keys, you have a non-custodial solution, you have the keys on your phone, and whenever you come back online, you synchronize with some kind of LSP, like kind of a centralized server node, and you can receive payments through them. The LSP could open channels to you, and all this kind of nice stuff. You can also use them basically as signers, as HSMs. So basically, you can, with LDK, you can take just the part of LDK that deals with signing transactions and verifying what you're signing. And you can take that as an individual kind of thing, self-contained thing. And with this, you could create some kind of signer that's aware of Lightning. So I think there's already some kind of HSM for Lightning. Or I mean, in a way, an HSM for Lightning is pretty simple. An HSM for Lightning is just something that signs a transaction. The tricky part is you want to see what that transaction is doing. You want to kind of understand what the transaction is doing in order to understand, oh, I'm making a payment of this amount, or maybe I'm just forwarding a payment, all this kind of stuff. So in order to be able to do that, you not only need to be able to sign a transaction, which is easy, you also need to be able to understand what's going on in the transaction. And for that, you need pretty much a Lightning implementation. So LDK can provide that, and you can use that to kind of inspect the transactions and see, oh yeah, this one is good. This is just a forwarding. This one is not. Or you can also build like a proper full node, more similar to C Lightning or LDK or LND, assembling all the various parts of LDK. So this is, yeah, I can skip this. There's this implementation. If you want to look at it maybe later when you're going to work on your thing, you could look at the LDK sample, which is like a sample, very minimal sample node that connects to Bitcoin so to Bitcoin Core RPC to monitor the blockchain, and you have like a very basic sample node. So maybe this can be interesting later on. I forgot I should zoom in a little bit. Can you all see from the back? Or okay.
Is it mandatory to run a full node on the same machine?
No, for LDK you have like an abstract concept. So we'll get that later at the blockchain data section, but you have kind of an abstract concept of you need to provide information to LDK about transactions. So you need to tell LDK, oh, this transaction has been confirmed, or this transaction showed up in a mempool. But you don't need necessarily a full node. You can do that with whatever way you want. You just need to provide this information to LDK somehow. So okay, so that's a sample. Can ignore this. In terms of architecture, so this is like a diagram of the architecture. So in LDK, you have all of these kind of independent pieces that you can assemble together. So on one side, you have all of the networking, which basically means communication with other Lightning nodes. And LDK implements the encryption protocol, the noise protocol. It implements the messages, like the message structures and stuff. So you can talk to other nodes very easily. Like you can tell LDK, I want to open a channel to this node, and LDK is going to create all the necessary messages, encrypt them, and send them over some arbitrary channel that normally it's a TCP socket, but it could also be a web socket, for example, if you're running in the browser. LDK is going to send you asynchronous events whenever something happens. So for example, you can get an event when another peer connects to you, or you can get an event when your invoice has been paid. So let's say you create an invoice, and when somebody pays that invoice, you get an event. And you can also go pretty down in the internals, pretty deep down in the internals of LDK. Maybe I'm going to show you this as well. Just Lightning. So this is the Rust documentation for LDK. There should be an event enum. So these are all the events that you could get. So for example, I'm ready to, I guess this is when you're ready to open a channel, you need to create the funding transaction, or when you can spend something, or when somebody spent something, when a payment is sent, when a payment is failed. All of these are events that LDK is going to give you, basically, and then you can decide if you need to do something based on it. So for example, on a mobile app, whenever a payment is sent, you would show, payment successfully sent, or whenever a payment is failed, you would show payment failed. Then you have persistence, which is obviously very important in Lightning. You need to persist the channel state, like the state for all the channels. And again, in LDK, that's pretty kind of high-level abstracted. So LDK is going to give you like a binary blob, and it's just going to tell you, save this somewhere. And then when you, for example, need to restart your node, you're going to have to provide back this binary blob. So you don't need to understand what's going on. You don't need to understand the specific data structures. You just need to find a way of saving this binary data and then getting it back whenever you need it. You have a wallet kind of section of LDK. This is just the part that creates transactions. So for example, when you say, I want to open a channel, you need to find some UTXOs that you can spend. You need to construct the transaction in the correct way. You need to sign the transaction, you need to broadcast it. Maybe broadcasting is more in the chain interaction side. But anyway, every Lightning node internally still has an on-chain part, an on-chain section, which is also the part that you would use, for example, if your peer tries to cheat you, you need to react, you need to construct a specific transaction that can punish your peer and take all the funds. And then finally, there's chain interactions, which is just monitoring blocks and the mempool. So keeping an eye on all of your channels, seeing if your peer is closing them or if your peer is trying to cheat you again. Also broadcasting your own transactions. So when you want to open a channel, you need to broadcast the transaction yourself. And all of these are kind of abstracted concepts. So you could replace, there are defaults, but you can implement your own chain interaction whatever way you want. So it could be a full node, or it could be talking to an Electrum server, for example. You could replace the wallet. There's an example that uses BDK for the wallet part, because they're all kind of modular and independent. And also LDK has language bindings. I think they don't use UniFFI, or at least until recently they didn't. I don't know if they've changed something. So they made their own kind of framework, but basically works the same way. So you have a Rust library, and then you can call into this library from Java, Kotlin, Swift, TypeScript, JavaScript, or C++, which again means you can use this library even in mobile apps, for example, even if your app is written in Kotlin or in Swift. Now, so peer management is one of the structures that you have in LDK is a peer manager, which is like the structure that manages the communication with your peers. What's inside LDK is this section here, like in gray. So you have a peer manager, and the peer manager also need to talk to the channel manager, so it can basically notify peers when there's something happening on the channel side. So for example, the channel manager will want to create a new channel, and so I need to tell the peer, I want to actually create the channel. And also there's the gossip sync part. So gossip in Lightning terms means exchanging data about existing channels. So like Lightning is a kind of a global network of interconnected nodes, and the way my node knows about other channels. So if I want to send a payment, I need to know which channels are available, which channels I can use. The way my node will get to know them is by gossiping with other nodes. So the other nodes will basically tell me, oh, I know about this channel that exists. This is the UTXO on chain that opened the channel. These are how much fees that this channel is charging, or if you want to send a payment over this channel, how much fees you have to pay. This is all considered gossiping. And it's also part of what you end up persisting in your node, because otherwise, every time you restart your node, you would have to reconstruct the full view of the network, which would be very slow and inefficient. So all of these gossip data are also stored and persisted together with your node. And obviously, the peer manager, since it's the component that is talking to other nodes, is going to receive these gossip messages, and is going to pass them to the peer-to-peer gossip sync part. And I should also mention there's another thing which I think is called VSS, if I remember correctly. But basically, LDK has this way of doing fast syncing, it's called, because again, this gossip syncing takes a while, because you need to, let's say you're a fresh node, you just come online, you're going to connect to some node, and you're going to start receiving from this node some channels. Maybe then you connect to another, and you start receiving a bit more. So it takes a while for you to construct like a complete view of the network. And so there's another way around it, which is a bit more trusted. I don't know exactly how it works internally, but basically you can download this gossip data from some semi-trusted server, essentially. And I think this is called fast syncing. And I'm sure there are more advanced. I'm guessing you're not just downloading a package and just trusting it. So there's probably some kind of validation going on. But again, I just wanted to mention that's one possibility. So for example, if you're a mobile wallet, you are online for a few minutes at a time, you cannot really wait to connect to a bunch of peers and wait to get the gossip data from them. So normally on this kind of mobile wallets, for example, or maybe web wallets as well, you would use this kind of fast syncing method just to very quickly catch up with the view of the network. Yeah, and this is all async. So LDK, all of the I/O stuff are using async Rust, which we haven't really seen. But in short, it's basically in Rust, async is implemented as a trait. So you have a trait in Rust which is called future, and the future is something that you can poll. So, well, maybe I'll show you very quickly. No, not this one. No, this one. So I think it's in the, yeah. So this is just to mention, when you use async, you are effectively creating structures that implement future. And then on a future, you can basically keep polling a future. And every time you poll it, the future is going to tell you, I'm done or I'm still pending. So the poll result is either pending or ready. And so you can do async I/O and async computation basically with this, because from you, this is all abstracted away. So from you as a user, you just say await on a future. What's going on inside is there's some runtime that's polling the future, and every time it's pending, it's gonna go to sleep, come back again until it's finally ready. And LDK uses async a lot for the I/O part, and normally it uses the Tokyo runtime. So Tokyo is one, or like the most commonly used runtime for this. So, well, yeah, this is just to mention, if you end up using LDK, you're probably going to end up using Tokyo as well for async I/O. You can find a lot of examples, so that's not, even if we haven't really seen it in the lectures about Rust, it's going to be, I think, pretty easy to understand. It's nothing crazy. One last thing I wanted to mention, just to clarify. So again, I was saying this gray part here is what LDK provides. Everything else, you provide it yourself. So you have to provide the networking part, essentially. There are default implementations, so there's something you can take from LDK and just use it. But if you want, you can also implement it in a customized way. So as I was mentioning before, for example, you could connect over WebSocket, for example. So if you make a web wallet, obviously you cannot, from a browser, open channels directly. You cannot open raw TCP sockets from a web application, because the browser sandbox will prevent you from doing that. But you could, for example, connect to a WebSocket server and then use maybe this WebSocket server as kind of a proxy for connecting to real Lightning nodes. And so you can implement this custom networking logic. LDK doesn't care. As long as you send the messages it tells you to send, and you give back messages you receive, LDK is going to manage the messages. The way you get these messages doesn't really matter. And then you're going to have access to a list of peers that you can, I don't know, can look at list your peers. You can disconnect from one. You can see their public key, this kind of stuff. This is all provided to you by LDK. Well, persistent storage, it's pretty simple. So everything is gonna be serialized into some binary blobs, and then you decide how to store them. You can store them locally on your disk drive. You could store them somewhere in the cloud, so you could sync them to Google Drive, iCloud, whatever. That doesn't really matter for LDK. You just have to implement this persist trait. And again, there are sample modules, so you can take like an example code if you don't need anything fancy. Otherwise, you can provide your own custom implementation. Blockchain data. So blockchain data, I think it's explained more in depth later on. But basically, the main way LDK keeps track of the blockchain is by using this block connected and block disconnected API. So you're basically telling LDK whenever a new block is connected to the chain, so whenever a new block comes in, or if there's a fork. So if not just a fork, if there's a reorg, so some block that you had previously connected, now due to some reorg, it has been reorged out of the chain. You need to tell LDK, this block has been disconnected. So again, you don't have to understand really what's going on the Lightning protocol side. You just take blocks and pass them to LDK. But there's also another secondary way of talking to LDK, and this is basically this is designed to be used in more bandwidth constrained environments where you cannot download every single block. So also, if you have a full node, you have full blocks available. You can just take these blocks and pass them to LDK completely, like the entire block. But if you are on a mobile device, you don't have a full node running on your phone. There's another way which is more compatible with Electrum servers, and Electrum servers are the main way of doing it, but there could be others as well. Basically, in this other mode, LDK will tell you, I care about, like, please keep an eye on this transaction ID, or keep an eye on this UTXO. And if you see that the UTXO is spent, you tell LDK that UTXO has been spent. Or if you see that a specific transaction ID appears in the mempool, for example, you tell LDK, oh, I've seen this transaction. This is much more lightweight because you don't need to download full blocks. You could have, for example, an Electrum server. You can make a query to the Electrum server and say, do you know this transaction ID? And if the Electrum server says no, transaction hasn't appeared yet, or if the Electrum server says yes, just get the transaction instead of downloading full blocks. So wallet management is, again, sometimes you have on-chain outputs that you need to spend. For example, when you create a channel, you need to spend some of your UTXOs to fund the channel. But also when a channel is closed, you're going to have some on-chain outputs that you can spend with your part of the money. And basically, LDK is going to tell you, you have this, which is spendable now. Sometimes you have time locks involved as well. Because, for example, when you force close a channel, if you are the side force closing a channel, your part of the money is going to be time locked for a while. Because if you remember, in Lightning, you have the punishment system. So if you force close the channel, you could be trying to cheat. You could be trying to publish an older state. And so your part of the money is locked for a while to give the other peer a chance to punish you, basically. So after a while, I think it's like a week or something, your funds are going to be spendable by you. And so in that case, LDK would tell you, oh, these funds that were previously time locked, now you can spend them. And then, again, you manage the wallet side. So you would construct a transaction, you would add these UTXOs, and you would spend the funds. So networking, again, it's kind of abstract. So it could be TCP sockets. That's the default. That's the way the actual Lightning Network protocol works. If you want to connect to other normal nodes, but you can implement your own whatever communication channel. You just need to have some kind of bidirectional channel. It could also be like USB serial. So for example, I could have a device that's connected via USB, and I use this serial connection to send messages back and forth. It doesn't really matter for LDK, as long as you have some kind of send this and receive something. Private key management, you can, again, do kind of whatever you want with it. So for example, there's a default way. I think the default way is just you generate a 32-byte secret, and that's it. That's your main key, and then you kind of use that key. You kind of derive from that key. But you could also use, for example, if you have a mnemonic, you could start from a mnemonic, derive your mnemonic first, and then use that as a key for your Lightning node. So in that case, you would have just one mnemonic to back up. And with that mnemonic, you could have a bunch of on-chain money. And also, with some derivation, you could have the Lightning funds being kind of related, connected to that key. And again, LDK has this kind of generic API for signing. So LDK is going to tell you, please sign this, and you can sign it whichever way you want, which could also mean maybe talking to an external device. So if you're using other wallets, maybe you don't actually have the key for on-chain funds on your node. You can talk to an external device, get the signatures, and then broadcast your transaction. So the transaction filtering is the thing I was mentioning before. So if you're running, they call it a light client. So if you don't have a full node, you cannot take full blocks and pass these full blocks to LDK. So you can use this transaction filtering API in which LDK is going to tell you which transactions it cares about, basically. It's going to tell you what to look out for, and then you can provide just this transaction, just this, like whatever is related to the things that LDK cares about. Fee estimation is, again, kind of an abstract concept. LDK, you can implement your own fee estimator if you want, which could be, maybe it's just a proxy for a call to a full node. So if you have a full node available, you can call estimate smart fee, which is the name of the Bitcoin Core RPC command. Or you could connect to some server and ask the server to estimate the fees for you. This is kind of a problem for, maybe it doesn't seem like much of a problem, but it is a bit of a problem for light clients, for mobile wallets especially, estimating fees. Because the problem is, if you have a full node, you have a view of all the transactions that are coming in. You have a view of the past few blocks. So you can see, well, in the previous blocks, transactions from 5 to 100 SAT V-bytes were confirmed. And also, for example, even just figuring out the fee rate of a transaction pretty much requires a full node, because in the transaction itself, you don't see the value of each input. You only see the value of the outputs. But the fee is the difference between all of the outputs and all of the inputs. So if you want to calculate the fee, if I give you a transaction and I tell you to calculate the fee of the transaction, you need to somehow fetch the value of each input. And again, this is tricky. If you're a light client, you don't have all of the history, all of the UTXO set in your, I don't know, on your disk, in memory. So estimating fees seems like a super simple problem, but in practice, even if you could, let's say, monitor the last few blocks, for example, I could, as a mobile wallet, I could download the past 4 or 5 blocks. I would also have a hard time figuring out the fee rate of the transactions contained in this block. So then I would have an hard time figuring out how much I should pay for a transaction I want to make. And I'm mentioning this because with BDK, we spent some time kind of researching methods of doing fee estimation for light clients. In the end, we came up with a machine learning thing which worked on average better than Bitcoin Core, but in the worst case, it worked terribly. So we never really released it. At some point, it could also estimate negative fees, which doesn't make sense, obviously. So anyway, we spent a lot of time, so we know this problem is kind of hard, estimating fees in mobile devices. So what most wallets, mobile wallets end up doing is they just have some third-party server that you can call and you can ask for a fee estimation, which is not great in terms of trust. So for example, this server could lie to you and make you pay more than you should. But yeah, it's kind of the only way, really, because it's pretty hard to have a trustless fee estimation if you don't have access to the full blockchain, to the mempool and stuff. Well, and finally, broadcasting. LDK will tell you, please broadcast this transaction. You can do it however way you want. Also, random number generation. You have to kind of provide your own source of randomness. I think that there's a default. Well, yeah, so in the sample node, they use rand, which is the main crate that's used everywhere in Rust for randomness. And this may seem like kind of a weird design decision. So why can't LDK create its own randomness? And the reason is the developers of LDK wanted to create a library that doesn't make system calls, because system calls require a system, essentially. So system calls are like opening network sockets, opening a file, getting the current time and date, or getting entropy, getting randomness. All of these are system calls. And if you are running on a desktop platform or a mobile platform, you do have an OS that can provide these things for you. But even just if you compile your project for WebAssembly, for example, you don't have an OS anymore. So you don't have, at least natively in WebAssembly, you don't have a source of entropy. You don't have a source of the current date and time. You can shim, kind of wrap these things. You can make them so you end up calling JavaScript functions. So you could have, specifically in WebAssembly, for example, you could have this thing that when LDK wants to get some randomness, it kind of ends up calling, I don't know what that's called, like crypto, secure, random, whatever from JavaScript. But that's, you kind of need to wrap stuff. Or also, if you run this on an embedded device, like an hardware wallet, in that case, you don't have any system at all. You don't have a clock. You don't have a file system. So basically, the designers of LDK decided to make a library that's pure in the sense that it doesn't make system calls at all, which means you can take this library, you can compile it for WebAssembly, and it runs. You can compile it for embedded hardware, and it runs fine. But that means that you have to provide yourself all of these parts. So you have to provide yourself the networking, the persistence, the randomness, because LDK cannot do it internally, which I think is a really good design decision, especially if you want to make something that's very modular, very flexible, that you can use in many different environments. With BDK, initially we were not really following this philosophy, but then later on we changed it, and we also decided to aim for no system calls, again, to make BDK work on hardware devices and stuff. So what time is it? 10. OK, so I think these are guides. So maybe we can, I don't know. Yeah, these are like code examples. So maybe you can go through them very, very quickly. Then you're going to get back to these when you end up implementing your own node. Yeah, but very, very quickly, this shows, for example, how to open connections. If you remember, LDK doesn't provide a specific networking implementation, but there's another crate, which is Lightning Net Tokyo, which is a networking implementation that uses TCP sockets and uses Tokyo for the async runtime management, basically. So if you don't want to implement yourself the connection, you can just use this other crate, which is not LDK itself. LDK is just the Lightning crate, and then you have all of these other crates that implement default behavior. And so this is an example of connecting to some peer. It's an async function, so you need to await the result. And then when you have, yes, I guess what they do is they try to connect, and then they keep polling the peer manager until they find the node ID in the peer manager. So basically, once the peer manager confirms, OK, we're connected to this peer, they exit from this loop, basically. Because when you connect to a peer, it's not just opening a TCP connection. You also have to basically make an handshake with them. You need to first establish an encrypted channel, and then there's also kind of a lightning handshake that happens on top to basically figure out whether the two nodes are compatible with each other. Because if they're not compatible, obviously it doesn't make sense to remain connected. So they'll exchange, which features they support, which kind of extension they support. So all of this takes some time. So when you want to connect to a peer, you connect, and maybe the connection itself goes fine, but then you need to wait for the handshake to complete. And so you would do it in this way. You would take your peer manager, iterate all of the peers you have, find the specific node you're trying to connect, and then once it finally shows up, you can exit. So opening channels, you need to provide some kind of configuration. So for example, announce channel means whether the channel is public or not. So whether the channel is going to be announced to the whole network or not. Most of the time, if you're a mobile wallet, you don't want to announce channels. You prefer to keep them private, because a mobile wallet is going to be offline most of the time. So you cannot route payments. So it doesn't make sense to announce it. Other people will try to route payments over you, and they're going to fail. So it makes sense to just keep it private. Obviously, you can set the amount of the channel. The push amount is how much your peer is going to get initially. So for example, obviously the default is, the simple case is, I open a channel with somebody, I provide the liquidity. So the initial state is going to be all of the liquidity is on my side. But I can also open a channel. I put the liquidity in myself, but I want the other side to get something initially. So for example, if I want to make a payment while opening the channel in one go, so I can open a channel that's already a bit unbalanced on the other side. And this is called the push amount. Yeah, and then you can just call create channel on your channel manager. Your channel manager, if you remember, is connected to the peer manager. So when you want to create a channel, the channel manager is going to create all the messages. Is going to give this to the peer manager. The peer is going to send the messages to your peer, and everything happens from that point on. And then you can wait for events like, well, this is when the funding generation ready, is when you've talked to the other peer, and they agree with you on opening a channel, so they are okay with you opening a channel. And so this is the point when you actually create the transaction. So this is when you're ready to create the funding transaction. So you create the transaction, and then you tell LDK, well, this is the transaction I created. Closing a channel is pretty easy. You can either, this is trying to cooperatively close the channel, which basically means you talk to your peer and you say, look, I want to close this channel. Can you cooperate with me on this? And if they do, you create a new transaction. You don't end up publishing the state transaction. You create a new transaction that just spends the channel UTXO and creates two UTXOs, one for you and one for the other peer. If they don't agree, or for example, if they are offline, so you cannot cooperatively close, you can force close a channel, which basically means publishing the last state transaction, which is also going to mean your funds are going to be time locked for a while, and then you can spend them later on. So if you want to send payments, you can, well, this is how you parse an invoice. So there's the invoice type provided in LDK. You can create an invoice from a string, and this returns sort of obviously a result. It could fail. And from the invoice, you can figure out who's your payer. So who's the payer is yourself. The payee is who you're trying to pay. You can get the network graph from your router. So the router is basically a piece of LDK that will look at the gossip data and construct the actual graph of the network. And so then from the router, you can make queries and say, find a route from myself to this other node. Yeah, and you can basically, this is the way it would work. You would call the router, try to find a route from me using this network graph to this payee. The features are, for example, the invoice could tell me I support multi-path payments, which basically mean the person that's getting paid, so the payee, could in the invoice signal that they support splitting a payment and then re-merging it together once it reaches them. So if you cannot find a route for the whole payment in one go, you can split the payment and then basically have multiple routes that they all converge back to the payee. And so this is why you have this kind of features thing, because you need to tell the router whether you can use this feature or not. First stops and last stops are basically routing ints, so you can tell, well, these are the usable channels I have, so you start from these channels. These are the last ops that are that the payee told me I can use, maybe through the invoice, the amount and stuff. And then you just create, just create the payment hash, payment secret, and send the payment. And again, you can monitor through the events. You can figure out when the payment has been successfully sent or if the payment has failed. And if you want to receive a payment instead, you need to create an invoice yourself. And so there's this kind of utility method, so you can create an invoice given a channel manager, because basically LDK is going to look at your channel manager to figure out what channels do you have incoming to you it's gonna, if those are private channels, it's gonna encode them within the invoice. And I guess it's also gonna look at things like your features, the features you support in your channels. And then, yeah, you can set description, amount. I don't know what the currency is, but I guess maybe that's a unit you want to use. I don't know. And then again, you can monitor the events whenever. So you create the invoice, you give the invoice to somebody else, and then when the when somebody pays this invoice, you get an event that says that you've received the payment. Well, and maybe before moving on, I've been talking for a while. Are there any questions in general about all of this? Or should we just keep going?
I have some questions.
Yeah.
Okay. You said that kind of transaction and data information are stored in binaries,
Mm-hmm.
but you need to have SDK to restore all of things, or you can just can switch to another client, another node implementation to restore everything.
I think maybe it's theoretically possible, but it would be, you would have to implement some kind of conversion, I guess, because LDK will give you its own data structures to store, and so then only LDK can load them back. Maybe you can implement some conversion. So maybe you could, sit down and take these structures and modify them for other nodes, but it's probably pretty complicated because different nodes they maybe make. Obviously, there's some parts that they all persist, but maybe there are other things that they specifically save while another implementation doesn't. So I think it would be pretty hard to convert between the two. It's mainly supposed to be, or it's only supposed to be used for the node shutting down and then restarting, and you want to restore the state you had before shutting down.
In the function for cooperation and closing channel, there is some kind of offset in time that is kind of set by default, or you can choose how much time do you wait.
Like a timeout. I think there is, yeah, there's probably a default timeout. I don't know, I would try searching for timeout. Well, I don't know. Yeah, I'm pretty sure there's a default timeout. So normally you would, well, most interactions in LDK are asynchronous. So in the sense that you make a call. So for example, going back to this sending payments, I make a call that says send payment, and this call will return pretty much immediately, maybe with an error, or it will return immediately, but it doesn't mean that the payment has gone through. I have to wait for the event later that says the payment was sent or the payment failed. And I think it's similar for closing a channel. I think you just say, I want to close this channel. It doesn't immediately tells you whether the closure was successful or not. You need to wait for the event. Maybe let's see if there's an event. Yeah, there's an event, channel close. Yeah. So you get this event if the channel actually finishes closing. So if you can completely close the channel, or maybe you're going to get
cooperating with the other node, or just closing channel and
I think this is
knowing how the closure happened.
I think this is in general. So whatever type of closure, well, there's a reason. So yeah, for whatever type of closure, you get this event, and then you can check the reason, and the reason could be cooperative closure or the peer disconnect. There are a bunch of reasons.
Okay.
But yeah, I think there's a timeout. I don't know how much. Normally in Lightning, in LDK, you can configure pretty much every aspect of your node. So I will look at for example, the user configuration, where you can set, whether you accept multipath payments, whether you accept inbound channels automatically, or if you want to manually accept individual channels. So there are a lot of these configuration things everywhere. So I guess somewhere you can configure the timeout as well. I don't know where, but
Thank you.
yeah, no problem. Okay. Any other questions or? Okay. Well, yeah, we can talk about blockchain data. So we've already introduced this a little bit before, but well, first of all, why does LDK need blockchain data? Because well, there are a bunch of things that obviously deal with on-chain transactions. So for example, whenever something happens on-chain, I will update the channel state. So for example, let's say a block comes in. I was in the process of opening a channel. I need to wait for a few confirmations. And when I see a new block coming in, I realize, oh, this channel is now fully confirmed, is now ready. So I'm going to update the internal channel state. Also, maybe LDK can update its set of filters. So for example, if you see a channel closure, if you see the channel closure transaction on chain, now you want to keep track of the channel closure transaction, not the funding transaction anymore. So you update your internal filters. Or also, LDK may need to broadcast transactions if it's necessary. So yeah, well, this is kind of same diagram as before. This is just showing you the Lightning block sync, which is one implementation of the feeding data to LDK that uses full blocks, I think. So I think the Lightning block sync is the one you provide full blocks to, and then it processes these blocks and gives them to both the channel manager and the chain monitor. Yeah, so the Lightning block sync utility, I think this is also another separate crate. Basically can pull from some kind of block source, and it gets full blocks whenever a new block comes in. Or if there are chain forks, it deals with those, so it connects and disconnects the correct blocks. And yeah, you can pull any custom block source, which a custom block source could be, for example, a connection to a full node, and you take blocks from the full node. So this is the way it's implemented in practice. Is you have a trait, so you can have you can implement the block source trait for whatever structure you want. So for example, for an abstract blockchain structure, and you need to be able to do this. You need to be able to get an header for a block. You need to be able to get the full body of a block, given its header, given its hash. And you need to get the hash of the best block, so the current tip of the chain. And then just by implementing those with the Lightning block sync, LDK can kind of do everything for you. And this is, again, what I was mentioning, the full block, the full block syncing method. So when you pass full blocks entirely to LDK. And then the channel manager is going to take the block, look at all of the transactions, figure out if there's some transaction that's relevant for your node. So for example, channel open, channel closure, cheat attempt, and stuff. And make potentially any, I don't know, it could potentially react to those. Alternatively, there's the filtering method, which is, again, designed for resource-constrained environments like mobile devices, for example. I think it's mainly designed to be used with an Electrum client or an Explorer server, which is basically the same thing. It's a different protocol, but you can ask for the same thing. So with an Electrum client, you can ask for all of the transactions that are related to a script pub key. So I can ask an Electrum server, give me all the transactions that either pay or spend from this script pub key. It's the same with Explorer. The difference is in Electrum, you have a long-running TCP connection. So you open a connection and you keep it running for a while. With Explorer, you make REST API calls, but it's the same thing. And basically, with the if you want to use this method, you need to implement this chain filter trait, and then LDK is gonna register things with you. So it's basically gonna tell you, I want to keep an eye on this transaction, or I want you to keep an eye on this output. And then it's up to you to do this, the correct way for whatever kind of blockchain way, whatever kind of blockchain syncing method you're using, and then you provide back to LDK anything that matches these filters. So yeah, if you don't have access to this kind of information about a new block being added, so for example in Electrum, you don't really get a notification whenever a new block is added. You can use these other traits, which is more transaction oriented. So basically, you're keeping an eye on some transactions, and you let LDK know when a specific transaction has been confirmed, rather than telling LDK, there's a new block, there's a new block, there's a new block. And yeah, and LDK will tell you basically all the things it cares about. So all the TXIDs, all the transactions you need to keep an eye on, even if they've been removed out of the chain. So for example, if they were confirmed before, but then there's a reorg and these transactions end up being dropped from the chain, you need to let LDK know. And finally, transaction broadcasting, that's pretty simple. You need to implement this broadcaster interface trait, and then LDK is going to call a method on your structure to broadcast a transaction whenever it needs to. So key management. The default key manager is a very simple implementation. You just take 32-byte secret, and you start using it as a seed for a BIP32 derivation, and then you derive, like your main key that's going to become your node public key, and then you can derive keys for every channel or keys for every on-chain outputs you own. And so if you want to use this very simple key manager, you can just create one given some random bytes, some random 32 bytes. Or you could also try creating a more unified kind of wallet where the secret is not just kind of an independent secret. Maybe the secret itself comes from another mnemonic or some kind of HD deterministic, hierarchical deterministic wallet. So I don't know why they use 535 specifically, but the way they, I guess, recommend doing it is, well, you have your main secret, which you also use for on-chain stuff. Then you derive your secret at index 535 hardened. Or if you want, obviously, you can use some other custom path. I don't know why they use 535 specifically. Maybe that's some standard written somewhere. And when you perform this derivation, you get 32 bytes of entropy, basically, that you can use for your key manager, for the LDK key manager. So now instead of having one key for Lightning, one key for on-chain, you just have one mnemonic, basically for everything that's derived in some way and used for Lightning as well. And this is an example of doing that, where you parse a mnemonic, create a seed from the mnemonic, then derive it down with index 535. Then you take the 32 bytes and use them for your key manager. And in terms of on-chain funds, there's an event you need to look out for, which is the spendable outputs event. And basically, LDK, whenever there's something you can spend, so for example, again, maybe a channel has been closed, so now you have some UTXO that's yours, that's your part, your chunk, basically, your share of the channel, the money in the channel. You're going to get this event, spendable outputs, that will basically tell you, oh, you can spend this and you can do whatever you want with it. So normally you would, maybe if you have this kind of unified wallet architecture, you have on-chain keys and you have lightning keys that they all derive from the same secret, but they're kind of separate. Maybe whenever you have one spendable output, you would move it to an on-chain key. So you have all the on-chain funds in the same set of keys, for example. Or you could, I don't know, you could have some logic like, oh, well, now I have these funds, I'm gonna go open a new channel again immediately. That's up to you. And you get this, I think it's an enum spendable output descriptor, because there are different, this is not really a descriptor in the sense of mini script descriptors, but it's basically telling you what kind of output it is, because sometimes, because you need to know that when you're spending, because sometimes you're spending like a single SIG output effectively. So for example, if I have a cooperative channel closure, the two outputs of the closing transaction are going to be single SIG outputs, one for me, one for the peer. So when I go spend it, I need to know this is a single SIG output. That's pretty straightforward. But if I, for example, force close a channel, then my output is going to be this weird time lock, and then after a while I can spend. So when I go spend, I need to know what type of output it is, essentially. And I think there are a bunch of different cases. So yeah, there are 3 cases. One is just an output, or a delayed. I think it means it's time locked. And a static payment output, I have no idea what it is. But anyway, you kind of need to know specifically what type of output you're spending, because the way you create the transaction is going to be a little bit different. And this is an example implementing this using BDK. So you can create a BDK wallet structure, and then whenever you get spendable outputs, you can have, let's see. I don't know why they filter static outputs specifically, but yeah, so you can get an address from the BDK wallet. You get a new on-chain address that you can send the funds to. Depending on whether it's a shutdown script, I think it means it's a script for a channel closure, which normally they call a shutdown of a channel. And well, at some point, you're going to use BDK for signing. I don't know where they're doing it. But all of this, by the way, it's if you want to see the full code, I think this is taken from LDK node, which is yet another project you can take a look at. So what I was showing you before is the LDK sample, which is a sample node built, I think, purely with LDK. And then, so they use LDK, and then they manually implement everything else. But then there's also LDK node, which is this thing here. LDK node is more of an actual node implementation, and they use BDK in here, I'm pretty sure. Let's see. Yeah, so in this crate, they use BDK for the on-chain side, for the on-chain part of the node. So you can, I don't know, explore in here. I've never really looked at it, so I don't know the structure of the code or anything. But yeah, if you're interested in integrating BDK and LDK, you can probably find everything here. Like, at least you can find you can take some inspiration from this, I guess. Yeah, then examples. So, well, again, the sample node, I think, is LDK sample. There's also other languages if you want to. There's also examples in other languages if you want to directly use LDK from, I don't know, from a mobile app, for example. And yeah. So I think this is it for the theoretical part. Do you have any questions about, I don't know, LDK in general?
You mentioned, but is it possible
Not really.
The on-chain wallet.
Yeah, for the on-chain wallet, yeah, that's more than exporting. You implement yourself the wallet, so you just implement it however you want. So, for example, you could, for the on-chain side, you could create a 2 of 2 multi-sig or single sig, whatever. So that's fully in your control. You cannot export the descriptor for the Lightning outputs, basically, because they use weird scripts that cannot be expressed as descriptors. So this is why I'm mentioning they call this expandable output descriptor, but it's not really a full descriptor because Lightning scripts cannot be expressed as descriptors. But for the on-chain side, yes, because that's fully in your control. So you could have multi-sigs, you could have single sig, whatever. Okay. So, well, if there are no other questions, I can start showing you the workshop thing, and then I think we can start, or you can start working on it after the break. So, well, we're going to have to make some changes. So if you look at the documentation here, they talk about this website, but I think it's offline now, so we cannot use it anymore. So yeah, we're going to have to make some changes, but basically for the workshop, you go clone this project, which is github.com/tnull/ldk node workshop. And you're basically going to end up with like an empty, like the skeleton of a very, very simple Lightning node, pretty much. And the goal of this workshop is implementing the connection with another node, opening a channel with them, getting an invoice from them. Obviously, the invoice, you get it off-band, you don't get it through Lightning, and then paying this invoice. Ideally, with this website that used to be online, this would also work as a faucet. It would also work as an Explorer node. Now that it's offline, we're going to have to change it a little bit. So I would just say we can use testnet or signet. Probably testnet is better because there's more channels, more activity there. So so my idea is, well, yeah, we're going to have to change these constants. We're going to have to find some reliable LDK, some reliable Explorer server. I'm going to set up my own node. So I'm going to give you the public key of my node. Or maybe even if you want to, you could open channels with each other, because that's, I don't know, that's cool. And there's no faucet anymore. So I should have some testnet funds. I can provide a little bit of liquidity. Otherwise, you can also go get it from faucets, like publicly available faucets. And then what you need to do is, well, this is already commented out, so it's kind of a step-by-step thing. So first you need to connect to the Explorer server, build a configuration builder, and then build a node, get an address, an on-chain address for your node, and send some money to it. So again, maybe you can ask me for testnet funds, or you can, if you have them, that's great, just use your own, or you can get them from some kind of faucet. Then you open a channel. In this case, they were asking all the students to open a channel directly to their node, to tnull's node. Here I would say, maybe I'm going to set up my own, but if you want, you can also connect with each other, because we're all in a local network, so it should be doable. Then, well, normally you would wait for a bunch of confirmations on your channel. Then once the channel is confirmed, you can get an invoice from your peer. So you ask your peer for an invoice, you pay this invoice, and you wait for the payment to be successful. Obviously, this is just the beginning. We have some time, so we have basically until lunch to work on this. So I would say maybe start just by implementing, these little things step by step, and then once you get it running, so you can actually, you've opened the channel and you actually paid an invoice, then you can work on improving it. And I don't know, I would say, get creative, just implement whatever you want. So some example could be, you could implement a command line interface for this. So you could reuse some of the code that you wrote yesterday with Rusty line, and you could have like a command line where you say open channel on the command line, and you actually open a channel. Instead of hard coding it here, instead of hard coding the channel open parameters, you could do it at runtime with a command line command. Or I don't know, if you want to build, maybe in these few hours you cannot really build like an API and a web app and everything. That would be too much. But I don't know, like in that sense, I would just say, get creative. You can explore the Lightning documentation. I don't know. There's really a lot of things you can do with Lightning. You can also try opening, like creating kind of a network instead of opening a channel. Just with one person, you could try opening multiple channels. You could try to make multi-op payments. And I don't know, for example, in your node, you can also intercept payments. So you could have, for example, when somebody tries to pay through your node, you could intercept the payment and, I don't know, maybe accept it, maybe make it fail. I don't know. There's a lot of things you can do. If you have some ideas, you can also ask for help, obviously, if you need it. And I would say, yeah, just start small, start with the basics. When you get that running, get creative and I don't know, play with it. That's the idea. Just try a bunch of different things, see what works, see what doesn't. Yeah, that's it. So do you have any questions about the workshop? Or
does SDK support Signet?
I think so. Yeah, so LDK works on any network. I suggested testnet because we've had issues with Signet, with wallets not supporting, with other Lightning wallets not supporting Signet. So for example, let's say you connect to some node. Actually, I don't even know if there's an actual Signet Lightning network. I don't know if there's actually a bunch of nodes out there, or let's see. Yeah, I don't know, but what I wanted to, ideally you could also connect. Yeah, so there are some nodes. You could also connect to the larger, network and try sending payments to each other through the network as well, not just directly one-to-one. So I was mentioning testnet because normally in testnet it's a bit easier, I think. But yeah, you could do Signet as well. It doesn't really matter. Obviously, if you use testnet, you're gonna have to use a testnet Electrum server, and if you use Signet, you need a Signet Electrum server. I can recommend for Electrum server specifically, there's a nice website which is like Bitcoin Electrum. Let me see. This one. So on this website, you can find a list of Electrum servers. These are all mainnet servers here. But if you scroll down, there are other networks as well. There are shitcoins as well. But you can find TBTC, which is testnet BTC, which is this one here. Or I think it's SBTC. So SBTC is Signet BTC, Signet Bitcoin. And there are these two servers on Signet. Or TBTC, there are a few more. These are testnet Electrum servers. So you could use these. Or, no, wait, they're using Explorer, right? Yeah, so for Explorer, I think you can just use mempool.space. So I'll do a test myself. I'll send in the group chat the URL for both Signet and testnet, so you can just use mempool.space for that. And then, yeah, if you're on testnet, you can go to a testnet hosted. If you're on Signet, go to a Signet hosted.